Hi guys, we are here to resolve some issues from the community of the Eskimos, and because they have some problems in hunting and store them in the Ilgo cache, we will to provide some solution for them. And these solutions are common in the caching. So we will review our codes with this environment and this example, and then we will extend that to Redis. But for the proof of the concept, just we will make it very simple and describe it as a code in .NET. So let's go. We will define one class with the name of frozen catch. In this class, we will define the form of the model that usually Redis use to save anything in there. So because we don't have Redis and for simplicity, we will define the model in here by ourselves. So let me paste the model in here. Briefly, if I want to describe that, we will have the data that will cache it. We want to add another field for frozen add that is the time of the saving the data in the cache, and also melting time is equivalent with the expire time of the cache. And also we have another method is expire that checks the frozen time and melt time and the current time, and we return one boolean to us. This is a very simple class, and for the another class we will to define Ilgo cache will acts as a cache, for example Redis or memory cache or hybrid cache and this kind of things. But for simplicity, we define one class in here, and in there we will simulate the caching with one class. So this is Igloo cache, and in here let me add the needed using. In here we have two methods. One method is for setting in the cache, and one method is retrieving from cache. Freeze is equivalent with the setting. In there we just set in the dictionary the item with the hunting key, and in fall we will retrieve from the igloo, and in there if any fish or any salmon or other things exist in there, the hunter will get from there and no need go to hunting. In there just we simulate with one simple concurrent dictionary, and we save in the dictionary and get it from there. It's very simple just for concept. And in another class we need to define hunter class. Let me add the using. Oh, I have a mismatch with name. In here, we should add double O. Okay, Hunter class will simulate the user actions. For example, the user will retrieve some data from database, and we will redirect it first to the cache. And if the cache is exists, we will retrieve that from the cache to the user. And if it's not in the cache, we will send it to the database. So Hunter is the user in here. If the Hunter finds something in the igloo, we will file it and return the item for it and write it for the user. But if we can't find that salmon or that fish in the igloo, we will send it to the hunting, and a new expedition will be happen. In new expedition, we will simulate some time consuming action. In here, it can be database round trip. So because it is time consuming, we had some igloo for that. Okay, and after hunting, we will retrieve the result and also create new cache and save it in the igloo and freeze it in there. Okay, that's enough in here, and we can go to program CS and wiring all these things to each other. Okay, let me just add the using of them, and in here we have one hunt key as a Solomon alpha, and if in the igloo the Solomon alpha exists, we will retrieve it to the hunter. But if we can't find it and if it is out of stock, we should say the hunter to go for hunting. And in here we simulate the hunting and requesting for the Solomon from Algo 7 times, and in there we will send the hunter first of all to frozen catch async, and we described it as before. If it can find from Ilgo, we will retrieve it, and on the other hand we will send it to the expedition. Okay, now in here let me run the application. It seems everything is correct, and usually the software engineers do like this and they think it is enough. And you can see in here the first hunter go to the hunting and it's time consuming. After that we successfully caught the Solomon and save it in the cache. The second hunter will be find that from the cache, and the third one as well, and the next one. But in the fifth hunter, because the Solomon is not accessible in the cache, we say to that we don't have it and you should go to hunting. And this hunter will wait for hunting in here, and after hunting we will save in the cache, and these hiccups will cause the application to be slow, and the application will continue for other hunter very easily. But the problem is in here. Why we don't want to fill the igloo with the Solomon before it is out of the store? So the first tricks comes in here, which usually we don't use that in the real world. So let's modify this approach to have better and faster cache. The first thing that we should do is in the frozen cache. In frozen cache, instead of melt time, we should replace it with two new fields. And also I should have a new constructor for that. Okay, and in here, okay, and also we should adjust this expire and introduce two new methods for covering these fields. One method is fire that we already have it, and just we replace the melt time with hard melt time, and also we have is fresh that check the frozen at and the soft melt time, and in warning melt that we check the hard melt time and soft melt time with each other. So in here we will to start new hunting when we are in a warning melt. For this aim we should also adjust something in hunter as well. First of all, we fix the frozen cache and add soft melt time in here. Timestamp that. Okay, I added 5 milliseconds for this one, and I also remove this one from here. Okay, and in hunter we should add another method that is very important for us, and it will act as a background hunting. The hunter in the background should go to hunting and bring the fish to the igloo. I will define that method with the aura early refresh async. We should early refresh the cache with when the aura has been seen for the hunter. And in there, it is just very simple wrapper on go on new expedition method, but there is a very small difference in the calling of this method. In the calling of the method in here, in when the item is not null, we should check more things. We should also check is warning melt and is fresh as well. So let me replace the code with this one. In here, if the item is fresh, we will immediately return it. And if it's in the in warning melt, we should start our every refresh async method in the background. And we don't want to block the application for this one. And next hunters when comes, they will give their fish and go, but the hunter in the background will continue its hunting to fill the igloo with the fish. Okay, it's enough for this one, and let me run the application for see the result. As you can see, the first hunter will go to hunting and bring the fish for us, and we get the archaic salmon with this ID. The second one as well can use from that one, also for the third one. But in here you can see we serving a stale data row, and we should refresh the data with a new one in the background. So our refresh will be started and the expedition will be started. But for the fourth hunter, we will provide the stale data for it, and the expedition will be continue for us. And we don't want to wait for the new. And finally, at fifth step, we can get the hunting and refresh the igloo with the new one. None of the hunter will not wait for the fish, and in the background we feed the igloo with the hunting, and this enhancement will increase the performance of the cache, and we don't want wait like the caching for fill the data in that. Now our village is better, but it's not enough. Imagine that the hunter is late and many person comes to the igloo and request the fish. What should we do? We should lock all of them in there, or we should return something for them and handle them as soon as possible to doing something. This is the next step that we will improve in our cache. This part we will demonstrate another technique with name of negative cache. In negative cache, we will say to hunter as soon as possible that this hunting is not exist anymore and you can try later. So let me first of all change hunt key to another thing like wall, and also also in hunter, when we want to retrieve it, just we check it if hunt key, for example, that contains something like Solomon, you should retrieve these kind of things, and maybe this one. But if our hunt key doesn't in kind of Solomon, we share the return null value to the hunter. And also we need to add null for giving in here and run the application again. You can see the first hunter goes and can't find this wall, and the second one as well goes and can't find, and this going and coming back will be time consuming for our application and in here for our village. So for each hunter we will go to hunting and see the wall is not exist in the lake, and it's better in here to at the first hunter we inform other hunters that the wall is not in the lake and you can come back and wait for later. So let me change something in hunter class, and the method of get a new expedition async, we should add this code in start of that, but it needs one new class with name of empty hunt cache. So let me create that one. This class will inherit from frozen cache because empty cache is kind of frozen cache, and in there just we will to return a empty hunt for the hunter. So let me come back to here. If the hunter key is wall, we should save the null value in the cache, and in the cache, and other hunters will understand this hunt is not available and will come back and we can save our time in hunting. Okay, first hunter find that it is empty, the second one as well, third one as well, and this hunting, and we don't want to lose our time on hunting something that was not exist anymore. Now our application is better, but we still have some issue, and we can even have better performance in our igloo management. So let me first of all, for showing the issue, set the hunt key with the previous one that we had it in the igloo, Salmon Alpha, and also in hunter class in here that we check for existing of the Solomon, we should change it to this one. And if I run the application, we can see one issue in here. The first hunter go to journey and we should wait for hunting, and it brings our Solomon in here. In the second one we can find it very easily, but in the third one the soft melting time is started, so the journey will be started in the background, and the problem is in here. In hunt 4 another journey will started, and we know that one hunter in the background went to hunting, and it is not logical to have another thing. So it's better to lock the process with each hunt key and don't allow to duplicate the background job. For this aim, we should first add one class with the name of trivial single hunt, and in there we should use semaphore to lock the hunt key for the background job. In here you can see we get the hunt key and lock it with semaphore and wait for it, and after that we can allow to next hunter to go to the hunting. So now we need to use this one in our class and in our area refresh async. In here let me change the try code block with this code, and we forgot to add a disposable interface, and now in here we use our locking for hunt key, and if one hunter in background we should lock it and no send a new hunter to the journey. And if the next hunter go to hunter and see the igloo is fresh, it will write that one in the console. So let me run this one and see the difference with the previous one. As before, the hunter one will bring us the Solomon, the second one will use it because it is fresh. In the third one we understand the melting time is coming, and we send one hunter to journey in the background. And in here in fifth hunt you can see the second hunter released from live, locked and go to the igloo and in there see that the new data is in there. So we can use new Solomon for this hunter and the hunters that exist after that. But you can see in here that in the first one, our refresh is not exist and we will postpone hunting after the first hunter come back. So now we again make our village better and the management of the igloo faster. Now how we can implement these tricks in the Redis. First of all, let me start from softtl and hardtl. Redis built-in just have hardtl, and whenever that time expires, the Redis will remove that from the database. But how we can add softtl to there? We should save this item in the body of the item that we will cache in Redis and in the payload. As you can see in here, we have one data, and in another field we will add soft melt add, or for example soft delete or something like that. And in code we should check this soft melt and do something that we showed in our codes. For the another thing, we have swr stale while revalidate. In this technique, as you saw in the code, the data is stale, but we can use it in one period of the time, and in that period we can refresh in background. The flow is like this. The request comes to Redis. If can't find it, it will fetch from database and send it to user. But before sending to user, it will save in Redis cache. This is the simple flow of the typical Redis, and also this flow. If the request exists in Redis and it is fresh, we will return it to user immediately. But this path is new. If we hit the stale data and the time is after softtl and less than hardtl, we will revalidate in background and fetch the data from database and manipulate the Redis with that data. But in this during of the time, we will return the stale data immediately to user, and in background, the refreshing the Redis will be happen. So Redis doesn't have these tricks built in. You should program that in your code and add some code blocks like what I showed to you in your application. The third one is single flight or Stampede protection. In there, many consumers will request to Redis cache, and Redis cache don't want to send all of them to database. Just like one of them, and other users will wait to this locked one, and that locked one will go to database and bring the data and save in Redis, and release will be locked. And after that, other users will use that key in Redis and retrieve it to the users. So we don't send too much requests to the database. And this one again is not built in the Redis, and you should write the code similar to what we did in the application. Last but not least is negative caching. In negative caching, sometimes something is requested too much, but we don't have it in the database. So it's better to save that one with a specific key in the Redis. And Redis, instead of going to database and database say, I can't find it, Redis can find that this key not exists in database and retrieve it as soon as possible. And this one also is very simple approach that just you should save one key in the Redis. This is all things that we implemented in this video, and I hope it will be useful for you. So subscribe in my channel and support me with your likes and comments. Bye bye.